Distinguished guests, friends and colleagues, ladies and gentlemen, welcome to this public lecture. My name is Danny Kuan. I am Dean of the Lee Kuan Yew School of Public Policy, and it's my great pleasure to get to introduce the topic and the speaker, who actually needs no introduction, of course, but I will go through the motions, and to say a little bit about the lecture. And then at the end of it, I will also moderate the question and answer session. This is the Lim Tiam Seng lecture series. It is named in recognition of Mr. Lim Tiam Seng, founder and current group advisor of the Chip Eng Seng Group, who donated a personal gift to the Institute of Water Policy here at the Lee Kuan Yew School, National University of Singapore. Over these past decades, Mr. Lim has led the group on its amazing journey from a sole proprietorship, a very small business, to today being one of the leading main contractors and property developers in Singapore. A number of us were fortunate to get to attend his 80th birthday celebrations just a couple of months ago. Today's is the first of the Lim Tiam Seng lecture series. The speaker this afternoon is, in my mind, about as perfect as one can get for this inaugural lecture. Professor Tan Gee Paw has been key in developing Singapore's water supply, most notably and memorably for many of us through the so-called 4 national taps: imported water, water from local reservoirs, new water, and desalination. Mr. Tan served as chairman of the PUB from 2001 through just last year, 2017. His career in environmental and water management goes back decades. Professor Tan has been awarded honorary doctorates from universities around the world. He has won practically every significant prize in science, technology, and engineering in Singapore, from the National University of Singapore, and elsewhere. And at the Lee Kuan Yew School, we are fortunate enough indeed to have him as one of our very distinguished adjunct professors. This afternoon, Professor Tan will speak to us on learning from Singapore's journey to greater water security. The lecture will end promptly at 3:45. Now it remains for me simply to invite you to join me in welcoming to the podium Professor Tan Gee Paw.
Thank you very much for that glowing introduction. And I'm at a loss wondering who are you talking about. But it is indeed my privilege to be here this afternoon to deliver this inaugural lecture. And I'm glad that we have chosen this topic about water security for a small nation like Singapore. My involvement with water began when I first graduated from the university, and that was about 50 years ago, and I joined the then Public Works Department in Singapore. And I thought that they are going to ask me to put up buildings and bridges because I thought I graduated with rather good class honors. And I remembered the director of Public Works Department decided to send me to the then drainage department. And I said, my goodness, drainage in the local context means just the longkang. In other words, all the wastewater, the water that you don't want, make sure it gets to the sea before it floods the country. Then when I went to see the head of that department, to my horror, he assigned me not to the design and construction, but to the maintenance section. And there I was in the maintenance section for some 2 to 3 years, just maintaining all the drains in Singapore. But when I look back, I realized how important it was. Because in that posting, I came to know every drain in Singapore by their names. And when I meet my fellow colleagues in those days in the drainage department, we will not say, let us meet at the junction of this road and that road, but we'll meet at the confluence of this sungai and that sungai. Sungai in Malay means drain. And that's how I began my career. And friends, I never looked back, never had a moment of regret. Of course, the day came when we have to pull up all our water resources together, and that's when they remembered the engineer who began in the drainage department, and that's how I ended up in the Public Utilities Board. So for some 50 years, my experience in water resources, I would say, have been a beautiful story for me myself. And so I stand this afternoon not because of my intelligence, but because of how history has unfolded here in Singapore and the experiences that we have gained. So this afternoon's lecture is about how we try our very best over the last 50 years to improve water security for an island nation like Singapore. I've got slides here presented, and I've decided that I will just speak on the very key points for this afternoon's presentation, rather than to go rambling on and on. So let me turn to the first slide. It's called Key Policies. Strategic policies. This is like the agenda for this afternoon. And I'll be talking about water conservation, water pollution control. Part 3 is very important, strategic planning through, I must emphasize these words, systems thinking. It is central to what we do for water resources in Singapore. Then how we develop a water industry with water R&D. Then finally, I'll conclude very quickly with some very simple, obvious lessons that we have learned along the way. First, water conservation, key policies. Of course, we must begin with pipe leakage. It's such a common problem in many developing countries. Some of them reach 20-25% of the water leaked away. And unless we tackle that at the very root cause, from the day you lay the pipeline, you've got to make sure that it can last 25, 30 years and will not give you problems. But if it is done haphazardly, then you are just creating problems for the future. So it's just construction, maintenance. We've got to bring down pipe leakage. Singapore, we brought it down to about 5-6%, and I believe that is about the norm. It's difficult to go below that because sometimes out of that 5-6%, it's not all leakage. Sometimes it's differences in water meter reading. You have the bulk meter, and it's not so accurate. You add up all the sub-meters, smaller ones, and the two must tally, but they seldom tally, and the difference is called water leakage. Anyway, if you can reach 5 to 7% is a very good norm for all of us in all countries to try to attain. Otherwise, it's an effort in futility. The more plants you build, the more it leaks out. And if your consumption is high, even a 5%, 10% leakage is equivalent to 1-2 desalting plants. Imagine you build a desalting plant just to let the water leak away that way. Second important key policy that we developed is called pressure reduction for water conservation. And it's such a simple idea. One day I saw from our taps water just gushing out. I said, why don't we just reduce the water pressure? And everybody came back and told me, you do that, there'll be public complaints here, there, everywhere. You know, for every housing estate, there's a valve at the main pipeline that feeds into the housing estate. So I told them, let's do it this way, not to generate alarm, but every week you go down and turn the valve close half a circle. So we did that week by week by week, until we get the first complaint. Then we know that's about such a simple solution, friends. So we went through the whole of Singapore, turning down the valves until we get some complaints and we know we are about at the right order. So it's as simple as that. And we save 5 to 7% of the water consumed in Singapore. The next one is flow restrictors. Flow restrictors are just little thimbles, we call them. Yeah, just orifices, a disc with a hole drilled in the middle that you can attach to the tip of your tap. Very easily done, and it just restricts the flow, so that however large your daughter, my daughter, granddaughter wants to turn the tap on, it's just the same amount of water in terms of flow that will come out. It does not go gushing out. And we saved a lot of water that way. Next one is water efficient appliances. You know, we give ticks to the water, to the washing machine, 1 tick, 2 ticks, 3 ticks. Sometimes I wonder why don't we give them 5 ticks in one go and just ban all the water inefficient washing machines. But you know, people say it can't be done, there'll be market upheaval, but so let it be. So over the years, we have been controlling the imports. So the good thing in Singapore is we can control the imports. And we can ban water appliances that are very wasteful in the use of water, and therefore we tighten up right at the very source of its use the amount of water that is to be spent in that particular appliance. So that's just water efficient appliances. These may be very small steps that we take, but added together, friends, you can save something like 15 to 20% of your domestic demand. Then lastly, right pricing of water. This one is so important, I left it to the very end. Right pricing of water. In Singapore, we price water at its marginal cost for unconventional water. In other words, what's the price of that new drop of water that you need to produce? And we price all the water at that price. Then we add on a water conservation tax on top of that, so that it controls the demand for water. I remember the first time when we raised water tariff way back in the 1960s. It was the only measure that brought water consumption to a standstill, the growth of water consumption to a standstill. All the other appeals and measures that we did only slowed down the growth of water consumption. When you hit the consumer in the pocket, the reaction is always very evident. However, even that, raising of water tariffs can only hold back that growth for 2-3 years, then the same rates of growth will resume. That's water consumption. In other words, we realize we just got to change the mindset of the people through public education as we go down the generations. No other way, friends. And that's what we are doing, trying our very best, changing mindsets in terms of water usage. No other measure can really produce that kind of a change that is sustainable. So these are some of the very simple key policies. Key for us would be water pricing. We got to price water correctly. Many countries think of water as a right for them to have. Some countries don't price the water at all, and it is just impossible to manage an exponential demand. Just impossible. We got to start with water conservation, and the right pricing of water is critical. I have in my midst Professor Asid and his wife, Professor Cecilia, and they will tell you stories after stories of country after country. The right pricing of water is key in controlling the demand for water. Without these kind of key policies, friends, you'll be chasing the wind. You'll never win the battle in terms of water security. The next set of policies I want to go into very quickly is about water pollution control. It may sound very mundane, water pollution control, but let me tell you that for an island nation in Singapore, it is critical. Today, we seldom hear about water pollution control. We take it for granted, but it is one of the key pillars of our policies. And you'll be surprised at my first point. For water pollution control, Build a separate stormwater drainage system and used water drainage system. Separate the two. Right from the day that you begin thinking about water resources and starting to develop it, we need to separate the two systems so that rainwater falling on the land can be captured and used for domestic industrial water. The used water must be collected through underground pipes in a separate system and never mix the two up. Because the rainwater is such a cheap resource that you have, therefore you must not pollute it with sewage water, domestic wastewater, industrial wastewater, and so on. So in Singapore, we inherited from the British a small but separate system, rainwater system, that's the drainage, then a used water system, that's a sewage, and we developed on it that way up till today. Many countries do not do it this way, and they're all mixed up, including the US, a combined system, and they faced enormous problems. You see, in pollution control, there's nothing better than separating it out at the very source. Once it is combined together, whether it be in wastewater or solid waste, once it is combined together, later on you have to separate it, it's going to cost you a bombshell, if at all possible. So our policy right from day one in the 1960s was, we must have these two separate systems, and both must be developed. If the sewage system is not developed, where can the wastewater go except into the drains? And therefore, you want to keep the drainage system only for rainwater. You need a similar system, sewage system, just as extensive as a drainage system. And therefore, the two systems must be developed hand in hand. Many countries do not realize this, and therefore that which is not seen, which is the sewage system, is very often just neglected, not developed at all. Nobody sees it, so why spend money on it? And that impacts upon the water quality they have in the reservoir. So that one is a key policy that we have. And you would have thought that we should just stop there, separate the two water systems. Rainwater system, used water systems, two separate systems. But no, friends, even within the used water system, that has to be a separation. And that we learned from the 1960s. Next one is treated used water effluent, I skipped it, to be discharged into the sea and not into rivers. Now let me just jump a little. And that is true for us in Singapore. We realize that we are blessed to be a city near the ocean, in fact an island state. And therefore we escape the problems that many big countries with long rivers have, where finally the effluent from the city, where can it go? Back into the river for the downstream city to suffer. But if you are a coastal city like Singapore, all these things along these lines, do not send the sewage effluent back into the river and then try to extract water from the same river, maybe downstream. As much as you can, effluent water from the sewage treatment plants must go straight out to sea after proper treatment. So we adopted that policy right from day one for Singapore. All our sewage treatment plants, we call them water reclamation plants now, are sited at the coast where there's an outfall so that the effluent after treatment can be dispersed into the ocean with proper environmental impact assessments and so on. This saves us a lot of issues. All the rainwater can then be collected into clean water reservoirs, raw water. The next one is strict enforcement of regulations. Strict enforcement of regulations. It's no use having all the regulations. I remember we met with a certain country once and we had a dialogue and we compared our regulations and they got better regulations, more strict, but there was no enforcement. And we admired them for the very strict regulations that they have. But unfortunately, there was no enforcement, especially for industrial effluent. Let me now jump a little bit go back to the first one. Build a separate stormwater drainage system and a used water sewage system. Even within the used water drainage system, we will separate out the industries from the domestic. In other words, all the industries will discharge into a sewage system of itself that is separate from the sewers that are used for domestic. We started doing that in the 1970s. It's a massive program of recycling industries from domestic premises, take them out, send them over to the industrial estate, recycle them all that way. And we had in mind that one day, we should be able to treat the domestic wastewater, used water, upgrade it into potable standards and send it back to the population. And that was a key policy that we followed through all these decades. Industrial wastewater must be separated out from domestic wastewater so that we can keep in mind the reuse of domestic wastewater for the domestic consumption, and then for the industrial wastewater, we can recycle it after treatment back to the industries. We do not want to try to mix them up because the problems of a mixed domestic industrial wastewater will present very challenging problems for wastewater treatment. So that was started in the early 70s, and for the next few decades, we just followed it through. So today in Singapore, there are basically two separate used water systems, one for domestic, one for industries. It's not because the technology that we have for water reuse cannot tackle both kinds, but it is because we do not want to challenge that technology, the membranes that we have with industrial wastewater. Why do that if it is easier to recycle the industries this way? So the separate systems we have is, first on the surface, drainage system for rainwater not to be polluted, then the used water, the wastewater collected into a separate system, sewerage, and even within that, we separate the industries from the domestic. And we are reaping today the benefits of this very basic policy. You may say, you do not have, you're not affluent enough to adopt advanced technologies for water treatment and so on and so forth. What can you do? My advice is, these policies cost us nothing. It's just a policy to be implemented. It costs you so little. Prepare for the day when your country will be rich enough and you can afford advanced water treatment plants and whatever it is. But if you do not start this way, then friends, even the new technologies will be tested to its uttermost when you do not clean up the catchments this way. First, rainwater catchments on the surface. Next, the sewage catchment. Separate out industries from domestic. Then you're ready to take advantage of technology, and when your economy develops, you will be there. And that's what I've been advising many developing countries who want to know what kind of technologies we have, and they see it's so expensive. I say, no, you cannot jump into these expensive technologies straight away. Do your planning first, your policies, and that's why we started the Institute of Water Policy, because we realize that for many countries, we must begin with good, sound water policy upfront in order to resolve the problems further down the years. The next is public education. There you are, public education. After doing all this, the infrastructure, separating the clean water system from the wastewater system and so on, you need to teach and educate the public how to use it. In other words, the housewife, the hawker, the coffee shop owners, they must know that the wastewater must go down the sewers because you have provided that system. They must not throw it into the backyard drain that collects rainwater. You may say, but it is so common, such a common knowledge. But you'll be surprised you had a hard time trying to separate the two through public education. It's so easy to get a pail of dirty water from the kitchen and rather pour it down the sink to open the backyard door and throw it down the drain that goes into the reservoir, silage water. We did a lot of engineering design to try to separate so that the kitchens don't have a back door in some cases and so on. But there's nothing like public education and enforcement. so that the public knows how to use the infrastructure that you have provided for. Public education. And the reason why, you got to tell them the reason why. Many, as we develop in Singapore and we meet the people, so many of them say, then what is a drain for? You know, they thought the drain is for the wastewater from the kitchen rather than down the sewer, which is too small. Just throw it in one go into a drain in the backyard. And their question is always, when we confront them, they say, then what is a drain, the longkang for? And we've got to explain to them, every drop of water you throw into the longkang goes into the reservoirs, comes back into the tap. And then they realize, yes. And so it's public education that way. We are not there yet 100%, but I would say about 95% there in terms of this form of public education. Then the final key policy for water pollution control is this, and it will come as a surprise to you all. We call it Solid Waste Management Program. The Solid Waste Management Program is as massive as the water program. As massive, it's not even more. This is the refuse that is discharged from the industries, from the houses, and so on. And unless you have a strong program to handle such waste, invariably they'll end up in the water courses, create a water pollution problem, enormous water pollution problem. So we started in the early 70s. Every day, the refuse truck must go to the house, collect the refuse for safe disposal. Not into the water catchment, no more into the landfills that many countries depend upon, no more to the landfills because you leach out into the water courses. It's a massive program we started in the 1970s. It's not just for public health, but one of the driving reasons was water pollution control. Every day the refuse, especially in our tropical countries, they will rot and the salage water will go into the drains. Every day the refuse must be collected and disposed of. And we are proud of that we have achieved today something that we started some way back in the 1970s. Today, every ton of refuse that can be incinerated, and these are domestic waste mainly, that is organic waste, that's the worst kind of waste for water, the pollutive organic waste, they must be incinerated and not dumped. Then the inert waste that cannot be incinerated will be sent to an offshore landfill. And there they are more like for land reclamation because they are like construction debris, inert waste, that kind of a waste cannot be incinerated. So we have a very strong program from the 1970s till now to build refuse incineration plants. One of the driving factors is every ton of domestic refuse that is organic, that can be incinerated, should go to the incineration plant in order to save our water resources. That's why solid waste management and water resources are together in the same ministry. If you fail in solid waste management, then friends, we will not be where we are today in terms of the reservoirs that we have. So it breaks my heart when I see many developing countries and they take a photo of the river and you cannot see the water in the river. So full of flotsam. And they are wondering how can they tackle water pollution problem. And my answer is very simple. It's a solid waste disposal. The people must have a means to dispose of their solid waste in a safe way. It's more difficult to do than what I say. I know I'm just wasting too much time on some of this, but it's so important. You see, Singapore in the early days had a lot of squatter colonies. Squatters, they just spring up, there's no planning for them. So there are little lanes and footpaths that go from house to house, and it's just impossible to collect your solid waste every day. The refuse truck cannot get in. You cannot send men in all the way through. So you got to send the refuse truck in. But how to send a truck in when they only have little footpaths and the whole squatter colony is so huge? What can they do in the squatter colonies? They just throw the rubbish into the drain, into the small longkang next to their house, ends up in the reservoirs. So solid waste management is not just that. It has to begin with rehabilitation of the people. The squatters have to be cleared. Proper houses put up, in our case, HDB flats must be built with proper sanitation, with proper solid waste disposal facilities, so that the truck can go in every day to remove the refuse. So it's not so easy to say water pollution control must be controlled. It means a redevelopment almost of that urban city. And we saw all these problems in the 1970s, and so we had a very massive housing redevelopment policy, very active. The benefits are multiple. It's not just upgrading the living standards of the people, not just providing them with fresh water from the tap, but more importantly, sewerage to prevent water pollution control, and secondly, solid waste management so that they do not litter the environment. So I cannot overstress that solid waste management must be integrated with the water policy. If we fail to see this point, then your success in water resources management will be 70%, 80%. You'll never reach the level that you desire. In many countries, I know the two are separate. One government department takes care of solid waste as best as they can. Another one looks at how to supply the people with water, and the two are not linked. If the two are not linked, there's no way you can resolve this problem. It goes all the way down to the kind of housing development that we have. The capacity to redevelop squatter huts. Solid waste management program, often neglected. Friends, I know I have to finish by 3:30, something like that, Now let me go to the interesting part. All these are standard, you can read them everywhere. It's just common sense policies, and we just got to get on with it. Next, let me talk to you about the strategic planning with systems thinking. Way back in the 1960s, early 1970s, when we first formulated the first water master plan for Singapore, we understood that we got to handle water resources as a system. You cannot separate the sewage from the drainage, from the water supply. We got to bring them all together into a comprehensive system and tackle the entire system as a whole. And we came up with this diagram. We call it the water loop system in Singapore. And this was our thinking way back in the 1970s. Of course, you have the natural hydrological cycle. I call it the A loop. And that is a natural hydrological cycle. From the sea to the rain, then the storms, then we collect the rain in reservoirs, send them to treatment plants, supply water to population industries, collect every drop of it back into our sewage system, treat the sewage the sewage that came in, then some out to sea. And so the cycle goes on that way. This cycle is the most basic cycle. Every country has it. The trouble is subject to the vagaries of the weather. Then you realize that actually we have a system called B now, that we can take some of the treated used water. In the 70s, the technology wasn't there, but we dreamt of the day when the technology will be available, and we can do this, that we can take treated used water and reclaim it further and send it back into the reservoirs or send it directly to the industries, not so much to the population, for the population must go through the reservoirs back into the industries. And so by so doing, we would have a second loop this way that bypasses the hydrological loop. It shortcuts the hydrological loop. And more importantly, it is a closed loop. That is key. It is a closed loop recycling, and I'll talk to you about closed loop recycling in the slides to come. So that is a second pathway. We call it the B routes that goes along this way, from used water, treated, and reused again that way. Then, of course, we know that we can do seawater desalting. That's the C system, C loop, from the sea direct to seawater desalination onto the population, industries, collect them all back, treat, and back to the sea that way. So in effect, the water loop that we dreamt of in the 1970s, there are three loops, nested loops, I would say. And this is what I call by systems thinking. You got to tackle water resources as a system, as a whole. So we did that. In those days, the technologies were not available, but we know we need to plan the development of our infrastructure in such a way that when the technologies become available, we can implement all this. So this is the water loop. Let me go through each of the loop and give you the key factor that you need to know for each of these water loop. The first is the natural water loop, and it is from the storm water into the reservoirs, into the population, back to the atmosphere. And for Singapore, I think we are one of the few countries in the world where we have expanded our catchments from the central catchments, which is a protected water catchment, all jungle, no housing, no industries. The central catchments, pristine water quality. We expanded it into developed areas. There's housing, some light industries, and it's colored yellow. And so today, after we have tidied up all the catchments, cleaned them out, made sure there are no excessively pollutive industries, they're all taken out, resited into Jurong area for industries, cleared all the pig farms, the duck farms, and so on. And then we allow housing, limited housing development in these areas. We call them the unprotected water catchments. They're all colored yellow now. Then we build reservoirs to collect the water there. And of course, we need advanced water treatment, not just sand filtration. That won't do. We got to go for advanced water treatment because these are urban, even though they're supposed to be clean, but there's always some sludge water and so on, and you need slightly more advanced water treatment plants. Expensive, but has to be done. So today, like the Marina Reservoir, the Marina Barrage, the water comes from the central part of our city, fully developed. We trap the water there and we treat the water to potable water standards. So today, some 2/3 of Singapore's land area have become water catchments for us. There are some other fringe catchments. They're colored white. They are at the boundary edges. And this one is the industrial estate. We are not going to touch them. And these other ones are the fringe water catchments, where it is just too small for us to try to tap the water the conventional way. But we realized 1/3 of Singapore is good water resource that we want to tap. So we launched into an R&D program. We call it the dual system, where we can treat seawater as well as fresh water from the same plant. You see, conventional technology, either you treat wastewater, or either you treat the fresh water or you treat the seawater. But this one is a combined technology in a single plant that you can site at the river mouth. And when the rains come, you can treat the brackish water. When there's no rain and the seawater comes in, you can treat the seawater also. It's a combined plant that way. It reduces the cost tremendously. It's a technology we just developed in PUB about 10 years ago. We have deployed something like 4 to 5 plants now in Singapore. And it's an amazing breakthrough in technology. You imagine we don't have to build barrages. You don't have to build dams. You go to a big city in China, you cannot dam up the river because of the shipping and so on, but still you want the water from the catchment. So you just build a plant like this that can treat the seawater. When there are heavy rains, you can treat the relatively fresh water, and the plant can run whole year round. So with that, the day will come when we will be able to tap some 90%, 95% of Singapore's land area for rainwater. So that's the first loop. Now there's one key point that we need to remember about water catchments, and it is this graph called the storage yield graph. It is key to our understanding of water resources. I think we don't study this in the universities because it's a very specialized area, but it goes this way. Friends, I need to talk twice as fast. You have a particular catchment, and the rainfall is there. You can't change the rainfall. There are only two things that are variable. The amount of water you draw from the reservoir, we call it the yield of the reservoir, and the other one is the size of the reservoir that you're going to build. So there's the storage, and there's the yield from that storage. These are the only two variables. For a particular catchment, if you plot the yield from that catchment against the storage of the reservoir, it'll come out to be a curve like this. There you are. This is the storage capacity of the reservoir. This is the yield, the amount of water you can draw every day from the reservoir without the reservoir completely failing. That's called the yield of the reservoir. And it will always be a curve that rises steeply as you increase the storage. Then it flattens out and becomes almost the same as what we call the average rainfall. Of course, that's the maximum. You have an infinite reservoir, that's the maximum water you can draw, which is the average rainfall. The important thing to note is this. It is a curve of diminishing return. A curve of diminishing return. So when you are up there, for example, no use thinking of larger reservoirs, no use thinking of deepening existing reservoirs, because when you add more storage, the amount of yield you get is marginal. So it's the marginal effectiveness of a storage in the reservoir. Once you have reached a certain stage, you've got to think of other alternatives. It's no longer a question of storage. It's actually a question of the supply from the rain, which is the size of the catchment. And this is fundamental. If you ever build a reservoir and a catchment and you're wondering what's the size of the reservoir, always remember this curve. Where are you on that curve? If you're right down here, then you better try to think of how to add more storage so that you can increase the yield tremendously. We are up there, then please forget about building a larger reservoir. It's just marginally too expensive. So this is one of the key things that you need to know in a catchment storage reservoir. Today in Singapore, we are quite far up. That's why we are very careful about building more storage in Singapore. Of course, if the storage is very cheap, given to us for free, of course, we'll be very delighted. But to create storage that is of marginal return in terms of the yield of that system, we've got to think twice. Let's move on quickly. Now I'm going to talk about the second system, the system B, which is the wastewater recycling. This one is even more exciting. Remember, the catchment storage has got its limitation, but this one is even more exciting. You have, for example, the treated used water sent to water reclamation, and the reclaimed water of very high grade sent back to the population through the reservoirs or directly to the industries. Then we collect them back into the sewers. And so it goes round and round that way. We call it water reuse, a very common term. But the distinction is this. Many water reuse is linear. In other words, you take the domestic water, wastewater, you feed it to the requirements of agriculture, and it goes out to sea. It's not closed. It's an open loop. And there, in that area, in that kind of a reuse, the benefits are additional. But if you close the loop, then the benefits become exponential. And that's shown in this curve. It's an exponential curve. Think of it this way. If every drop of water that you use can be treated to the level that it can be used again, then it comes back to you. And if you continue doing that, you'll never need additional water, isn't it? Of course, technically that's not possible, not desirable even, but that's the whole idea. Now the import of this is this. You have a reservoir that can supply 100 million gallons a day of water to the population. If you take 50% of the wastewater and recycle it back after treatment into the reservoir, that same reservoir of 100 million gallons per day can supply a demand of not 150, but 200 MGD. If you increase the rate of recovery, instead of 50% sent back to the reservoir, you increase it to say 75%. Then a 100 MGD reservoir would be able to supply a demand of 400 MGD. That's the power of a recycling loop, closed loop system. Of course, those of you in electronics, you know what I mean by a closed loop. It's the gain factor of the closed loop electronic system. That's why sometimes the mic goes screeching because of the feedback, and it's a closed loop that way. Same thing in water. If we are able to close the loop, then the benefits are exponential. A 100 mgd reservoir can support a demand for 400 mgd. Only drawback is this: you got to be very careful. The water you send back into the reservoir from the wastewater plant must be treated to the highest standard possible. That's because in a closed loop system, if there's any pollutants that are left behind, it will accumulate in a closed loop system. The best way is make sure you keep bleeding some out. For us in Singapore, my own gauge is we can go up to about 75%. Beyond that, I would raise some alarm. Even though technically you can do it up to 90% perhaps. On PUB under Harisia, they now say the plant itself, the recycling plant, can go up to 90%. But the system as a whole, you can never reach 90%. 75% is about it. From the engineering point of view, there are many leakages. And 75%, I would say, is about a good maximum. We want to bleed some out just in case. So it is a system that you want to implement. It solves the water demand problem immediately, but it has got some drawbacks you need to be aware of. In other words, you must run your plants fully reliable in terms of how you operate the plant, of the standby, of the redundancies, of the technology that you put in. You must be 100% sure. Any failure, and this curve that goes out like that, you'll find it reverses. It'll go all the way down. Within a few weeks, the whole system will crash. Just as it improves exponentially, it'll crash exponentially, unstable. Therefore, you need to be top in your engineering in terms of water treatment. We are glad today the technology has arrived. We have tested it out for more than a decade. More than a decade. Well beyond WHO standards. In fact, the water is so clean from the new water plants, we cannot send it back through our normal pipelines. Pure water is very corrosive. You got to lay special pipelines for them if industries want this high grade of water. Some of the industries are not satisfied, electronic industries, with our PUB tap water, not clean enough for them. So they take our PUB water, upgrade it even further to a very pure level. New water, that is used water that is upgraded, comes in higher than the PUB normal reservoir water. Can you believe it? But that's the technology that is available today. And that technology is being improved decade by decade. Not just in terms of the efficacy of the membranes, but in terms of the cost. So we are excited because here you have a system that is closed loop. It's not like an open loop system where it is additive, but this one is a closed loop system, exponential. 100 mgd reservoir able to support a 400 mgd demand. Then we went on to the final loop, which is the loop C, seawater desalting. Here you are, seawater desalting. From the sea, you desalt it, send it to the population, collection of used water in the sewers up there and then back that way. And of course, the brine goes out to sea. It's an exciting area. When membranes came in, we decided, after we succeeded in new water, to go into membranes for seawater desalting. And of course, it's easier. New water, you got to take wastewater where the quality of the wastewater effluent is so variable compared to the seawater, which is only salt, some other pollutants that you need to remove. Much easier. So we went to seawater desalination, and we succeeded with membranes. So today we have a number of seawater desalting plants in Singapore, quite a large percentage of our total demand. And I always say this: when you succeed in seawater desalting, the ocean is your reservoir. The ocean is your reservoir. Now, it does not mean that we don't need any more of the reservoirs that we have built for rainwater and so on. The trouble with new water and desalted water is this: they are so clean that they lack the minerals needed for your body, and therefore we'll always need the inland water reservoirs so that we have a mixing of the two and it sustains the nutrients that you need for the human body. So the ocean can be your reservoir if that technology is available, and it is today proven, only thing we have to do is bring the cost down. It's energy intensive. And some people would say we have transferred dependency upon water to dependency upon energy. But actually that is not so. You look at Singapore as a typical nation, if you were to desalt half our water consumption from the sea, the amount of added energy that you need for that desalting process will come out to about 1.5 to 2% of the total energy requirements of Singapore. It's a very small percentage. And yet, we are looking at new technologies that can bring it further down. Exciting research going on beyond the polymer membranes that we have today. We are going into biomimetics. Then we are going into synthetic channels to look at all these things that will truly bring the cost all the way down. Mangrove swamps, for example, they are able to desalt the seawater, and I don't see huge PUB cables going in to do the desalting. It's able to do so. Our research is into that area, and we have succeeded in building a pilot plant. It's running for, I think, a few years now. I think some of my officers here should know. And it's exciting technology because the pressure that's needed is so low, much, much lower than for conventional seawater desalting. In fact, in my wildest dream, I dream of the day when you can go down to the sea with a straw made of this kind of material and just drink the seawater. And it'll be fresh water for you. When that day arrives, and it's not too far from the horizon, when that day arrives, I wonder why I have built all my pipelines in Singapore. But that's the excitement in the water industry, friends, in water R&D. And it all begins because we have the water loop. Back to the water loop, there you are. See, once you begin to think of the water as a total system, the advantage is you can see where the bottlenecks are. You can see where the technology is lacking, and you can say, if only I have the technology to do this, I'll be free to supply so much more water. Then you know where to focus your R&D money. That's what we are doing here in Singapore. We know where the bottlenecks are. We have focused R&D funds over the last 10 to 15 years in these bottleneck areas to open them up so that we can have the full benefit of the recycling and of the closed-loop system that we are establishing here in Singapore. We see this as the best way forward for an urban system, urban city like Singapore, for water sustainability in the light of climate change. One thing about the climate change that I forgot to mention, back to the storage curve, can my good friends send it back to me? Back to this curve. When climate change comes in, you'll be asking me, how will it impact this curve? It's a very interesting question. Climate change will have two factors. One, either you get more annual rainfall or less annual rainfall. You get more annual rainfall, of course, this horizontal line, which is the maximum, will go up. So the curve will be steeper and you're happy because for the same storage, you get more water. If it gets drier on an annual basis, then of course this dotted line will come all the way down and this curve will have to come down and you get less yield for the same storage, so you suffer that way. The other factor for climate change is extremes of weather. The wet months may be wetter and the dry months may be drier, or the rainfall may become more even throughout the year. If the rainfall becomes more even throughout the year, then this curve will not rise this way. It will rise even more steeply because you need less storage. In fact, if the rain comes every day the same amount, you don't need any storage at all. What comes in, you use, and you don't have to worry at all. It is because of the variability of the weather that you need the reservoir. What if it is pushed to the extremes, like it is in Singapore, as we see? Then, in that case, you need more reservoir storage, and this curve will flatten out that way. It will come down. But fortunately, in a tropical country like this, the impact upon our water resources will be marginal compared to what we have from other sources today. But those countries that are so dependent upon the reservoir system, please be careful with climate change, study this curve carefully, and study carefully the impact of climate change upon this curve that will hit your country maybe 50 years later when the reservoir is built. Let's move on, friends. I know time, I'll take just 2-3 minutes more. Let me summarize quickly. Friends, after my 50-year career in water resources, if you leave me alone, I'll talk. And this is just the gist of it. There are so many interesting personal stories that I want to tell, which I will eliminate today. R&D. Let's move on to R&D. We decided that we will go into R&D because it is critical to our development of water resources. From the water loop, we have identified those areas that are critical, where we hope R&D can produce the results and free the system for better usage. So we started R&D, and today I'm glad to say that from 2006 to 2020, we have got this R&D program. It was identified as a key pillar for economic growth. National Research Foundation was formed, and they provided us with $670 million to grow the water industry through R&D. These are all the rest. I leave it to you to read. Let's move on. And the strategic thrust to grow the water sector through R&D is simply this. We have technology development. It fits into cluster development, where the water industries are clustered together for synergy. Then we go for internationalization, where we learn from what other countries are doing, share knowledge with other countries. And that is the way forward to build a water industry here in Singapore. Let's move on. We had some targets. These figures are somewhat dated, but nonetheless it shows we started with 2006, the number of jobs, 6,000 in the water industry. Today we have something like 14,000. This, I think, is about a few years ago. Then the value added for the industry from 0.6 billion to 2.58 billion. Companies, from 50 companies to 200 companies located here in Singapore now. R&D centers from 3 to 25 R&D centers for water that we have here in Singapore. Singapore has become a hub today, a global hub for water R&D with 25 R&D centers. Many of them are foreign companies that saw the opportunities to do R&D here in Singapore because you opened up all our plants for test bedding. They are free to get a new invention, test it out, bring it to our plants, and we help them to install it in our plants, run it for a few years, give them a report on how they can improve their products even further. So we have become a test bedding center for the world because we do not hold any patents. That's critical. Many people ask me, why don't you hold patents? I found from my the other hats that I wear, that selling patents is a hard job. Forget it. So we don't hold any patents, and because we don't hold patents, people trust us. We are not their competitors. So they bring their new inventions, their new products to Singapore, plug into our plants, we try them out, and give them a frank and honest report. No competition involved. So they trust us that way. So today Singapore is a test bedding center for global water technologies. So R&D centers, and this one is a very interesting slide. It shows the economic technology nexus for water. You have on the horizontal axis the timeline from 1960 all the way to 2010. On the vertical axis, I decided to plot the GDP indexation for Singapore. And we measured the growth of GDP indexation with the years, and it's rising up this way. Then we plotted on this chart the different policies that we have implemented. And it's very startling. We started in 1970-something with the Upper Pierce Reservoir scheme. This is the first time we expanded water catchments and a new reservoir is needed. So it's very low technology. Then we went on, we completed the cleaning out of Singapore River when the GDP is pretty high, because we have to bring in factories to Singapore to provide jobs. With the jobs, they are now able to pay for the housing board apartments. We can then resite them from the squatter colonies into these new apartments. So the whole cycle has to come in. It's all dependent upon the GDP. So when the GDP has reached a certain level, it's time for us to clean up the water catchments. Otherwise, it's impossible. You recite the squatters, where are they to go? You got to provide them not with another squatter hut, but you got to provide them with a proper dwelling place with sewage, drainage, water pollution control, solid waste management, all nicely set in. That costs money. Where are they to get the money from? They must work in the factory. So the industries must come in, the entire economic cycle must move. And so when the GDP has reached a certain point, the call was made, let us clean up the water catchments, and that we did in the 1980s. Then by the time we reached late 1990s, we adjusted the water prices to reduce water demand. By that time, the GDP is quite high, and we find that we're able to do so. In fact, today, the average household in Singapore pays about 1% of the monthly income for water. It's very cheap. So we are there today. Then comes 2002, we decided it's time for us to introduce new water, which is pretty expensive. Then 2005, when the GDP has gone further up, we introduced the first desalination plant, and we raised prices for water. And in 2006, we started seriously R&D work here in Singapore for water. We started much earlier, in the 1970s, for new water, but we only picked up when we know the economy is good, is on the rising trend, and therefore time for us to start R&D for water in Singapore. So we can see that policy development must track economic development, even for water. So no use if a developing country with an economy that's yet to take off come in and ask me about how do we desalt seawater, what's the best technology. But economic development must precede all these things. Otherwise, I think it'll be hard going for the population to accept it. So policy development must track GDP growth for water resources. That brings me, I think, to the final point, the lessons learned. Lessons learned. Before I show the next slide, let me just go into some things. One of the early lessons we learned is this. For good policy development, especially in water, you need sound domain knowledge. You cannot get an accountant to do your water master planning for you. You cannot get a lawyer to do it for you. You cannot get a politician to do it for you. Maybe he's the last person to do it for you. You need people with sound domain knowledge in water, in all its aspects. May not be expert knowledge in one area of water, but overall in order to chart policies in water for the future. So domain knowledge necessary. That's the first water lesson. The second is this: we need long-term planning and continuity of policy. Long-term planning. In Singapore, when we planned for water resources in the 1960s, we planned for 50 years, 100 years. No such thing as a 5-year program. 5-year program is which plans to build, yes. But in terms of the strategic planning, we must go 50 years, 100 years. That's because water is a long-term issue, especially if you do systems thinking and the entire water resources, how to develop it in an integrated way is a long-term program. No short-term government can ever succeed. You got to be long-term. So there must be continuity in policy and all the other factors that are needed. Long-term. Next, of course, leverage on technology. And we do so. Singapore, we track water development in other countries from the 1960s to the 1990s. And you know who was our hero? Orange County. We followed Orange County exactly where they are going, how they are developing, until the 1990s arrived, and we felt the day is correct for us to launch in a big way into membrane technology, and that's where we are today. There's no there's nothing to be shameful about following other people, but always be prepared to catch the wind at the right time and overtake. So today we are a global water hub. We saw the science coming up. Membrane technology is the way to go. We poured funds into it, developed the first new water plant, and on we go. Today, new technologies are on the horizon, and PUB is always on the lookout. What's popping up on the horizon in terms of water technology? That's why I have in PUB some 40 PhD engineers. I think we're the only government agency that have got PhD people, especially in engineering. We started about 10 years ago, sending them for expert training in specialized areas of water technology, water policy, and we're still sending them. Today we have something 40-something PhD engineers in PUB itself, and they help us scan the technology horizon, pick up the winners as they could see it, bring them to Singapore, test out the new technologies, and that's the only way forward, friends. Leveraging on technology. Then finally, I want to say, involve the private sector. Involve the private sector. I know I can spend another hour talking about this PPP, they call it, no? But we develop a model in such a way that we are at all times responsible for water resources in Singapore, not only responsible, in control of water resources development in Singapore. We build many plants by the private sector, contracted out, but should any plant fail, PUB is always ready to walk in, take it over, run it. We have the capacity to do so. We have the trained manpower to do so. Simply because when any private sector plant fails, PUB is responsible, not the contractor. We cannot contract out that responsibility, and therefore PUB develops in-house capability. For all the plants, various types of plants, we always build, own, operate ourselves, maintain ourselves, at least 1 or 2 plants, to build up in-house technology know-how, and also to carry out further R&D in these new areas. So that's the crux of our partnership with the private sector. I know of many countries who privatize everything, and the water is in the hands of the private sector, and I think they will see consequences down the road. So water is so vital, it's a survival issue for Singapore, that we cannot let go of the total control of water resources for Singapore. We can invite private sector participation, but in a way in which we never devolve our responsibility. So please rest assured on this. Finally, let me summarize all these lessons into one cycle. It's this one: correct water policy development, feeding into a stable political climate, and it leads to economic development. Economic development allows us, through R&D, targeted R&D, to develop new technologies for water, and the new technologies will allow us more options are made available to give us updated policies for further development. And I would say this cycle is the same cycle you would see maybe in healthcare, in education, other areas. It applies also in the water story. First, begin with good water policy, embed it in a stable political environment. You'll lead invariably to economic development, which will then feed into your R&D programs, which are very expensive, and that will open the door to new technologies, new options, and new policies. So friends, in a nutshell, I know I've been touching a little bit here and there and never go down deep, but in a very nutshell way, this is what we have done in Singapore, and I believe it is, in a small way, a contribution to our global knowledge of how to build a sustainable water system for an urban city that is sited next to the ocean. Thank you very much.
I'm Paul Boon. I've worked in sewage department many years ago. Before the development of new water, there was industrial water. So I know Mr. Tan, but I do not know whether he remembers me. My burning question to ask is, our imported water from Malaysia were left in, I think, 2016. My question is, with all this development in new water and desalination, by 2060, do we still need imported water?
If my lecture this afternoon hasn't provided you the answer, then I have failed. And that's my only answer.
Based on your chart just now, you have indicated that the brine is being discharged back to the sea. Is it possible to harness them and sell it as a commercial?
There's no market for brine in Singapore, unfortunately. There's no market, it has to go back to the sea. Now, the more interesting question is, many people say, but there would be an environmental limit to the amount that you can dissalt from the sea, because you can't get the sea too salty, the fish will die, and so on and so forth. This is where we have an advantage. It doesn't apply to us because of this advantage. We are an island nation, and we collect back every drop of water that we send out to the population. So it works like this. I put it this way. We borrow the water from the sea, take out the salt, send the fresh water to the population. After they've used it, we collect back the water, put back the salt, and send it out to sea. As far as the sea is concerned, it does not know what has happened. We have only borrowed the water from the sea, used it, returned it back to the sea that way. In terms of saline content, the sea doesn't know. That's the beauty of it, of being an island. That's why we try to site our water reclamation plants, our desalting plants, new water plants, all together, side by side or within the same building. And we are able to achieve all this only because we collect back every drop of water that we send out. If you're not able to do so, as many countries don't bother to do so, then seawater desalting will get that area, that the sea adjacent, will get more and more salty. You can never solve that problem. So we are very fortunate as an island, and also because of forward planning, we got all our plants nicely located. Of course, there can be some distance apart from the outfalls and so on, but overall, we are just boring the seawater, using the fresh water, returning back to the sea, its original water, and the sea doesn't know what has happened to it. And that is the concept now that we are promoting for water usage in Singapore, that when we send the water out to the population, we are not selling the water to them. I know I'm
No, please go on, yeah.
We are not selling water to the people and they use it and it belongs to them, they use it. It's not that concept anymore. We are saying, we lend you the water for your use, you must return it back to us. It's like a library book, like a library book. You borrow from the library, after use, you must return it back to the library. And that's the concept that we are trying to develop here in Singapore for the population. That look, the water is not yours for you to discharge anyhow, for you to dirty any old house. You got to return the water, every drop to us. If you lose the water through evaporation, we want you to pay the charge for a new drop of water. Because it's like you losing your library book, You got to refund the library for the lost book. So water, we got to change our mindset, no longer selling water to people, but they borrow it on loan from us for a fee, treatment fee, they must return it back to us. Same thing with the sea. We borrow from the sea. After using it, we must respect the sea, return it back to the sea in its almost original condition. So it's sustainable. That's the only way in which water resources can be sustainable. Close the loop, get the right policies, and change the mindset of the people from buying water from the water supplier to getting it on loan from them to be used and return it back to them. Thank you very much for that question.
Thank you very much, Mr. Tan. I think that is a wonderful metaphor that we're going to need to end the session on. I apologize. This idea that sustainability means taking a holistic view on the way in which this very essential qualities circulate through the island nation and through our natural environment. To close the session, I understand that there's a little reception at the end as well afterwards, so perhaps you all could continue the conversation with that. But to close the session, could I invite you to join me in thanking Mr. Tan for an amazing afternoon? Thank you so much.